Pre-statistics. Graphing quadratic functions in vertex form. Lesson objective: graph a quadratic function in vertex form. Lesson objective: we'll begin with the property. Let f of x equal a times the quantity x minus h squared plus k, where a is not equal to 0. F is a quadratic function and its graph is a parabola. We say that the equation is in vertex form. So a big property of a quadratic is one of symmetry. And the vertex will either be a minimum, as in this case, or a maximum, in this case. And the vertex is always on this axis of symmetry. Graphs of quadratic functions in the form f of x equals ax squared. Example 1. Compare the graph of g of x equals 2x squared with the graph of f of x equals x squared. Solution: if we construct a table of values, pick some negative x's, some positive x's, and 0. Here we have the outputs for f of x, and this is the output for g of x. And if we plot these points, we can see that g of x is steeper than f of x. And the reason why this is the case is because we are multiplying the x squared. So this is what we call a vertical stretch by a factor of 2. Let's do another example. Example 2. Compare the graph of f of x equals 1/2 x squared with the graph of g of x equals negative 1/2 x squared. Solution: again, if we constructed a table of values, pick some negative x's, some positive x's, and 0. Here we have the outputs for f of x. Here we have the outputs for g of x. And graphing these, we see that when a is positive, the parabola is going upward, and when a is negative, it is going downward. And these two graphs are identical, except for the fact that if I take f of x and reflect it across the x-axis, I get g of x. And we can see that in the signs here. The signs are opposites of each other. Properties for the function of the form f of x equals ax squared. The graph is a parabola with vertex 0, 0, goes through the origin. If the absolute value of a is large, then the parabola is steep. If a is near 0, then the parabola is not as steep. If a is positive, then the parabola opens upward, and the vertex will be a minimum. If a is negative, then the parabola opens downward, and the vertex will be a maximum. The graph of y equals negative ax squared is the reflection across the x-axis of the graph f of x equals ax squared. Let's do another example. Example 3. Compare the graph of f of x equals x squared minus 3, g of x equals x squared, and h of x equals x squared plus 3. Solution: using our table of values, we have the outputs for f, g, and h. Plotting these, we can see for f of x, the vertex now has been moved down 3 units because we are subtracting 3. And for h of x, the vertex has been moved up 3 units. So when we add or subtract from x squared, we call this a vertical translation. Either it's going to go up or it's going to go down. Let's do another example. Example 4. Compare the graph of f of x equals x squared with the graph of g of x equals x minus 5 quantity squared. Solution: we pick some values of x, we substitute them in for g of x, and we have our outputs. Graphically, x squared is here, and when we plot these points here, we have this graph. So if we look, we see that the vertex is no longer at 0, 0. The vertex now is at 5, 0. So we can see the relationship with the value of h and the x-coordinate of the vertex. Let's do another example. Example 5. Compare the graph of f of x equals x squared with the graph of g of x equals x plus 4 quantity squared. So in this case, h is a negative 4 because this is x plus 4. So if you recall, our form is x minus h. So when we pick values of x and plug them in g of x, here's our outputs. Again, when x is a negative 4, we get y to be a 0 because negative 4 plus 4 is 0 and 0 squared is 0. Graphically, f of x is the blue graph, and this new graph, g of x, is the red one, and again, the vertex has been moved 4 units to the left, and this corresponds to the value of h. Translating graphs process. To sketch the graph of f of x equals a times x minus h quantity squared plus k, where a is not equal to 0, and this is known as the vertex form of a quadratic function. Number 1, we sketch the graph of y equals x squared. Number 2, we sketch the graph of y equals a x squared. So the value of a will tell us if it's going upward or downward, and it will also tell us if the parabola is wide or narrow. Number 3, translate the graph from step 2 to the right h units if h is greater than 0, that means positive, or to the left by the absolute value of h units if h is less than 0, negative. And this will change the vertex in the x direction. Number 4, translate the graph from step 3 up k units if k is greater than 0, or down by the absolute value of k units if k is less than 0. So this will move the vertex in the y direction. Example 6. Sketch the graph f of x equals x plus 3 squared plus 1. In this case, h is a negative 3, a is a positive 1, and k is a positive 1. So solution? So here's the basic x squared graph. And since a is positive, it's not going to have an effect for the new graph. But h is a negative 3, so it's going to go 3 units to the left. And k is a positive 1, so now our new vertex is at negative 3, 1. And this is verified by the table of values here. Using a graphing calculator, we see the red graph matches the red graph. Thanks for watching.